Okay, we are going to look at, I want to say this is problem 8. Let me double check real quick. It is problem 8. Okay, so we're going to look at problem 8 today from the free response packet. So this is the second time we're seeing this. So again, if you have not already done this one or given this an attempt, please stop this video now, give it an attempt, then watch it. Okay? So if you are continuing right now, then I'm assuming that you have tried this one on your own. So let's see what we got going on here. So the first thing we're supposed to do is we're supposed to sketch, the slope field, just like we did last time on the axis provided. So reminder, all we're gonna do, right? So I'm gonna kind of remind you on one of them and then I'll just kind of go through quickly and do it. So reminder what we do. You take any point that they give you. So for example, maybe I take this point. What is this point? That is the point 1, 2. And you plug it in for x and y. So in other words, I get dy dx equals, what did I say? I said 1, 2, so this would be 2 times 1 over 2. So I think you guys would agree that would be 2 divided by 2, which is 1, so -1. And then you just make a little slope, a slope line like that. That has a slope of -1. Remember, the big thing is if your slope's a little bit off, that's fine. Okay, you just want to make sure that if it's negative, it shows it's negative. If it's 0, it shows it's 0. If it's positive, it shows it's positive. Other than that, you should be pretty good to go. Okay, so let's kind of go through and do this kind of quick here. So first off, I'm going to notice that whenever x is 0, the whole thing is 0. So let's go throw those in. 0, 0, 0, 0. Then let's see. If we plug in, let's see, what if we plug, I'm going to just start plugging in a couple numbers here. So I'm going to plug in the 0.11. I think you guys agree that'd be 2 divided by 1, which is 2. So this is -2. So it looks like this. Then if we go to, let's just keep on going here. So if I plug in this point, this is going to be the 0.1. So actually, let's just think, is this thing going to be positive or negative? This is going to be negative because the y values are negative, the x values are positive. So this is going to be not negative, it's going to be positive, right? Because y is going to be negative, so it's going to be negative times a negative. So in this case, it's going to actually look like, it's going to look very similar to the last one. This one will be 2. This one will be 1. Let's move on to the other side. So let's do -1, 1. So now the x is negative, but the y is positive, so the whole thing's going to be positive. So it's going to actually look like this, right? Yeah, because it's going to be about, it's about 2. It's about, that looks like 2. The other one's going to be about 1. So this whole thing kind of looks, when we're finished, it kind of looks like maybe like that. Okay, and again, you can double check yours versus mine. So here's what they would be looking for probably. If I were grading this one, I'd probably be looking to make sure these are all 0. What else would I be looking for? I don't know. Maybe they'd be looking for, maybe they'd give maybe another point where these are, these are, up above this axis. I don't know. Let's see. What would they? I honestly don't know. I don't know how they would grade this one. Okay, let's keep on going here. So for this question, they say, hey, let y equal f of x be a particular solution to that differential equation, and then they give us a point, the point 1, -1. We want to write an equation of a tangent line at that point, and then use it to approximate. So we're basically doing linear approximation. So remember, we should be, whenever they say, hey, write the equation of a line, we should be super happy, because in order to write, we know that writing an equation of a line is really easy, right? In order to write the equation of a line, you need a point, which they gave us, 1, -1. And then we need a slope. So in other words, I need to know what is f prime of 1. Well, we know what f prime of 1, right, is, right? In fact, we've already done f prime. Actually, I'm sorry. I did say that slightly wrong. It's f prime of 1, -1, right? So it's at that specific point. So we're specifically talking about the slope. What is it? 1, -1. We're specifically talking about the slope right here. You may remember it. If not, who cares, right? Let's just be careful on it. So let's make sure we got what we got. So it was the point 1, -1. So this is 2 times 1 over -1. So that's -2, +2. So this is going to be equal to +2. Well, let me double check it one more time. I don't want to be wrong. So it was a point 2 times 1 over -1. That's -2. Yep, looks like 2. So our equation of our line is going to look like this. Y minus a -1, which is y plus 1, equals 2 times x minus 1. Then we're going to put it in the form of y equals f of x. So I'm going to move that 1 over. And this is the equation of my line. Now, then they say, hey, take this thing and use it to approximate this value. So I want to remind you what linearization is. Linearization is all it is when we have this curve like this, we make a line tangent at a point, right? So maybe we're making a line tangent here, and we use that line to approximate a value we don't know that's close, something like this, because the curve and the line are so close together that the line is a nice little approximation. So that's all we're doing here. So we're going to take this, and so really our function is f of x equals 2 times x minus 1. We're going to use that to approximate 1.1. So I'm just going to plug in 1.1 into this. And you were done at this point, okay? Again, could you simplify this? Absolutely. You are more than welcome to do it. What do we get? We get 0.1, right? Minus 1, so that's going to be negative 0.8. But you don't need to. Again, right? I know sometimes we like to, and I know I do too. But you can stop right there. Okay, let's move on to C. So this is just like the last problem we saw, right? They want us to write a differential function, y equals f of x. They want us to basically figure out what the position function is, knowing that it pops through, that it goes through the point 1, -1. So what was our equation again? Let me go and grab that. So here is our differential equation. Let's bring that on down. Come on down. Okay, so remember what we do. We're going to use separation of variables. So I'm going to move that y. So this is going to be y dy equals -2x dx. Then in order to solve this, we're going to integrate both sides. So I'm going to integrate and integrate. So on the left-hand side, I get 1/2 y squared equals -x squared plus some c. Remember, I do want to remind you that c is important. I'm going to say, I'll do this. I could use the C1. It doesn't matter. Maybe I'll change it. Again, it doesn't. I want to remind you guys, don't worry about the C1. This is just a personal preference. Now, I do want to solve this for y, but you know what? I think it's going to be easier right now to just plug in this initial condition. So this point, I'm going to plug in this point 1, -1. Now, the only reason is when I solve this thing, right? When I solve this thing for y, I'm going to have a square root. I feel like the math will be slightly harder. So I'm going to plug in this initial condition now. So let's see what we get here. Plugging in the initial condition, we get 1/2 -1 squared equals -1 squared plus c. So 1/2 equals, looks like -1 plus c. Adding 1 to both sides. That's 3/2, right? So 3/2 equals c. Okay, so let's plug that in. So we have 1/2 y squared equals -x squared plus 3/2. All I did, just to be clear, I just plugged it into here. Okay, now they do want it to be of the form y equals f of x, so we got to solve this for y. And this is going to be important on this one. So let's multiply both sides by 2. So I get y squared equals -2x squared plus 3. Then let's take our square root. So we get y equals plus or minus the square root, -2x squared plus 3. Now we got to be careful. This is supposed to be a function, right? This plus or minus thing means that we have two functions. One's the positive function, one's the negative function. We have to make a decision. Are we going to use the positive root or the negative root? Here's how we determine. We look at our initial condition, right? That's the point 1, -1. Which of these graphs, right? Let's just kind of pull them out. Which graph? This one or this one? which of these graphs is going to go through this point? Well, I think you guys would agree the output of a square root has to be positive, right? Otherwise, we're having we can't. It can't be negative. So it can't be this one because the output has to be positive, but it's negative. So we have to be talking about this one. So our final answer is that. Okay? And I think that's it, right? Yep, that's it. That's all I have for you on this one. I'll see you in the next video.